of Tanzania, quality education for all. The Open University of Tanzania, quality education for all. The Open University of Tanzania, quality education for all. The Open University of Tanzania, quality education for all. The Open University.
My name is Clemence from Faculty of Science, Technology and Environmental Studies, Department of ICT. Today we are going to start about addressing. And on addressing, we are going to base on the IP addressing. As introduction part, in computer networking, we have three types of addressing. The first one, we have IP addressing, also known as a logical addressing. We have a physical address. This is known also a MAC address. Also, we have the port address. This is the label for network application. So, as introduction for IP addressing, in a normal life, if you want to arrive maybe at a certain street or at a certain house, you need the address of that place or that house. So also in a computer network, if one computer want to communicate with another computer, need identification, and this is known as IP addressing. Each device want to participate on the computer network need an IP address. IP address is the identification of the devices that are participating in the network. So in order for a computer to communicate with the other computer on the network, if in the same network or to another network, it needs IP addressing. As we have introduced in previous lectures, that in computer network you have a frame, or we call other languages a packet. So a packet can be transmitted from one network to another network. So if this packet need to travel from one network to another network, it needs identification, where it comes from and where it goes. So this identification is known as IP address. This is 32 bits, or we say is 4 octet, and this is implemented on the network software. And also we have different class of IP address, and on IP version 4 we have 5 class of IP address. We have class A, we have class B, we have class C, we have class D, and E. But for this course, we are going to start about first three types of IP address: class A, D, and C. So to start class A, also before starting, we have to define the class of this IP address. On the IP address, we have two parts of this address. We have the network identification and the host identification. So these IP addresses are divided into two parts: the network identification and the host identification. On the network identification, this identifies the network, a particular network, and on the host, identify a host on that network. So we have two parts. We have the network part and the host part, and the length of these parts are depending to the class of IP address. For example, for class A, the first octet, as I've said that we have 4 octets, but on the class A, the first octet represent the network identification. and the remaining 3 identify the host. So the first 8 bits define the class A, that is the class A network, and the 3 octet define the host on the network. So the first 8 bits define the network, and the last 24 bits define the host. So in order to know the number of network on the class A, we have the formula that are used to derive the number of network on the class A. We have 2 power of n, and is equal to the number of the network on the class A. And the n is the number of bits used to define the network on the class A. So if we take 8 bits that is used to define class A, that we have 2 power of n, which we have 128. This is the number of class A. But in real sense, the 2 networks are reserved. One is used to define the network, and the second one is used to define the broadcast. So we reserve 2. So we have the 126 network of class A, that we have 128 minus 2, we get 126. This is the network on a class A. Also, on the second part, I will say we define the host, that we have 126 network of class A, but within that network we have the host. Now on the second part we have 24 bits that is used to define the host on each class A network. So to know number of network which can be connected to the class A network, we have also the same formula, but the meaning of n differ. So we have 2 power n is equal to number of hosts per each class A network, and then n now is stand for number of bits used to define the host in each class. In class A, the number of network of the host in class A. So in class A we have 24 number of bits used to define class A. So we have 2 power n. 2 power n. Now if you calculate, you use the calculator, and then you get about 16 millions number of hosts per each class A. So if, as you are a company, you are given a class A IP address, you can connect up to 16 million hosts per one network. So if you see, this is for huge company which can connect a lot of devices in a single network. So this is used for huge company. Also we have the class B. Now in class B, we see that in class A, the first octet are used to define the network. Now if we move to class B, the first 2 octets are used to define the network ID, and the remaining 2 are used to define host. So we have 16 bits for defining the network ID, and the 16 bits used to define the host ID. So as I've said, that we have 2 equal parts on class B, that we have 16 bits and for defining the network, and 16 bits define the host. And also if you convert the first octet or the first byte for class B, you'll get 10. So if you minus 16 minus 2, we get 14. This 14 will represent the network identification. And to obtain the number of the network of class B, we use the same formula. 2 power n is equal to number of class B network. So if you take 2 power n, now our number of bits defined in class B, we have 14. So we have 2 power 14, which is equal to 16,384. This is the number of class B network. So if you use on class B network, we can have up to 16,384 class B network. Now on the host part, we have 16 bits. So in each class B network,